This diagram, which I'll call the which test flowchart, helps you decide which of the 9 statistical test methods, or you can think of them as experimental designs, is the correct one to use that for all of the tests that we're going to cover in this class. So most tests that you go on to use at a higher level are going to be based on one of these types of analysis. And so once you understand the difference between these simple tests, then you'll be able to extend that knowledge to find the correct test for much more complicated experimental designs later. This diagram says research question is about ... at the top, and then it has an arrow pointing to the left towards the word association, and an arrow to the right pointing to differences. So we'll start on the right-hand side. Now this differences side has 3 arrows pointing down from it. So we have a research question about differences, and there are 3 categories. One is if the differences are between distributions. So that arrow points to the far left. Then we have differences between 2 means and differences between 3 or more means. If we go back to the middle of the diagram, differences between distributions, another way of thinking about how this is different than the differences between means is that this is a categorical variable. All right, so differences between distributions, we have 2 arrows pointing down from there. The one to the left points to the chi-square test for independence, and the one pointing straight down is to the chi-square test for goodness of fit. The differences side of the diagram has a group of tests that are below the arrows that point down from differences to between 2 means. The first distinction is arrows pointing towards related to the left versus independent pointing to the right. On the related side, the arrow splits into 2 other choices, and those are labeled parametric to the left and to the right, non-parametric. The parametric test for related means, when there's only 2, is our paired t-test. The non-parametric test for related means is the sign test. Now, the difference in whether you're going to use a parametric test, which is basically shorthand for saying it is based on the normal distribution, and we're going to use a mean and a standard deviation in the calculations for it. The non-parametric tests are used when the assumptions for the parametric test are not met. So the non-parametric test, that's the equivalent to the paired t-test, is the sign test. All right, going back to the differences between 2 means, we have the right-hand arrow labeled independent, and we have the same split between non-parametric and parametric tests on this side. The parametric test to use to test for differences between 2 means that are independent is the independent samples t-test. If we have the same experimental design, but we don't meet the assumptions for the t-test, then we'll use the non-parametric equivalent test, which is called the rank sum test. All right, so there's 4 tests that allow us to test for differences between two means. If we look one step back up again and we say research question is about differences, but we go to the far right and we're looking for differences between three or more means, and those means are independent from one another, then we also have a choice between a parametric and a non-parametric test. The parametric test is called ANOVA, capital A, capital N, capital O, capital V, capital A, which is an acronym for analysis of variance. All right. So ANOVA is basically an extension of the independent samples t-test to three or more means. The non-parametric equivalent to this test, if the assumptions for ANOVA are not met, is called the Kruskal-Wallis test. So that is the non-parametric test to do if you have independent groups and more than three or more means to compare. Going back to the top of the diagram, if our research question is about association, that's our arrow to the left. If our association is between two quantitative variables, then we'll use correlation coefficient and or regression analysis. If the association is between two categorical variables, then we'll use the chi-squared test for independence. So the chi-squared test for independence can be used in different situations, whether we're looking for patterns of association between two categorical variables, or we're looking for differences between distributions of categorical variables. All right, so across all these different statistical tests, we need to know if the variables are quantitative or categorical. We need to know how many groups we want to compare, whether we're looking for a difference between means on our quantitative variables, and whether we're looking for association between quantitative variables or categorical variables.